Today's daily LeetCode problem of the day is most beautiful item for each query, number 2070. For this problem, we're given a 2D integer array items, where items of I is going to be equal to price and beauty. So this denotes the price and beauty of an item respectively. We're also given a zero index integer array queries, and for each query of j, you want to determine the maximum beauty of an item whose price is less than or equal to queries of j. If no such item exists, then the answer to query is 0. We want to return any answer of the same length as queries, where answers of j is the answer to the jth query. So, for example 1, we have the items that is $1, 2 level of beauty, $3, 2 level of beauty, $2, 4 level of beauty, $5, 6 level of beauty, $3, 5 level of beauty. We have the queries 1, 2, 3, 4, 5, 6, and our output for this will be 2, 4, 5, 5, 6, 6. And the reason for that is we are outputting the maximum level of beauty we can get for the price. So if we have $1, the max beauty we could get is 2. If we have $2, the max beauty we can get is 4. If we have $3, the max beauty we can get is 5. If we have $4, max beauty we can get is, again, 5. If we have $5, the max beauty we can get is 6. And if we have $6, again, max beauty we can get is 6. And that's all we need to do. So how are we going to approach this problem? To solve this problem efficiently, we're going to use a combination of sorting and binary search. So first, we're going to sort the items based on price from least to greatest. Right? We will then compute the maximum beauty up to each price. So as we iterate through our sorted items, we'll maintain a running maximum of beauty values. And this means for any given price, we'll know the maximum beauty available up to that price. And then we can answer the queries using our binary search. It's as simple as that. So let's go ahead and jump into the code. It's kind of similar to what a dynamic programming would be, but this is not dynamic programming. We are just kind of computing up to each price point what the best bang for buck item is, and then we're going to use that information later on to pick our item. So let's go ahead and do the code. We're going to have an integer array called, this is not going to be in our sort, so we can take it out of our sort. We're going to have an integer array called answers, and it's going to be a new integer of queries.length. That is because we have that many queries, and that's how many answers we want to put out. We can then arrays.sort our items, and this is going to have a function within it, also known as a lambda function. So the lambda function simply means we have a very tiny function that we only ever need to use once in this program, and you can define a lambda function by simply doing a dash and then an arrow. And so all we're saying is we're going to take the elements in items A and B, and we're going to sort them by comparing the integers in A of 0's position and B of 0's position. And we already know that the 0 position for each element in items is the price. So our lambda function is taking one element from items and another element from items and comparing them based off of their monetary value. And that's all that is doing. So now that we've sorted them, we can then compute the maximum beauty up to each price. So we're going to have an integer max beauty. So we'll call it max B. It'll start out as 0. And we can simply calculate this by using a for loop. So for int I is going to be equal to 0 as long as I is less than our items.length, I will increase. For our max beauty, it is going to be as simple as max b is equal to math.max of max B, comma, items of I of 1. So we're just going to look through each item. We're going to look at its beauty status, and we'll only ever update it if we find something that's greater than what we currently have. Otherwise, we will change the, the beauty value in it. So let's say, let me sort these real quick. So after sorting it, you get each element in monetary order. So afterwards, when we solve it, we're going to look at the monetary value compared to the beauty value. So 1, the new max is 2. We look at 2 and the beauty is higher, so the new max is 4. We look at 3, well, this is lower than 4, so we can update it to be 4. Look at the next one, that's 5. Okay, so that's greater, we'll take that value. And this is 6, so that's greater, we don't have to touch that value. Our issue arises when we have two numbers of same monetary value, but they're going to end up with two different beauty standards. And this is because one updates before the next one, which has a higher value. Well, for this problem, we don't actually have to worry about this issue, as we're going to use binary search to solve it. And with the binary search, it's going to search in a way that it looks at the ones that are going to be higher on the list first. And because of that, we don't have to worry about duplicate values with one less than the other. It will find the one with a greater value, and I'll show you guys that later. But until then, let's go ahead and implement this by updating items. So items of I of 1, we're going to change the second value, the beauty value. That's going to be equal to max B. We're going to do that for each value. Now, to answer the queries, we're going to have another for loop where we integer I is equal to 0 as long as I is less than our queries dot length. I can increment, and we're simply going to update our answer of I is going to be equal to, we're going to call to our binary search function where it's going to look at our items and queries of I, which is what we want the answer to be based off of. After that loop will finish, we can then return our answer. So let's go ahead and define and build this binary search function. So it's going to be a private, it's going to return an integer. It's called binary search. It's going to receive a 2D integer array. We'll call it items again, and an integer value target. So for a binary search, we are going to get the left value, the right value, and the current max beauty. And while our left value is going to be less than or equal to our right value, we're going to identify a midpoint. Then we will check if items of mid is equal to our target price. If it is, we will update it, and then we will shift the target over 1 to check again. And we will continue to do this until we're no longer either in the right area or the value is no longer valid. So we're going to have integer left is equal to 0. Integer right is going to be equal to the last element, so items dot length minus 1. And then our integer max B again. That's equal to 0. So for our binary search, we're going to have a while loop, and while our left value is less than or equal to our right value, we are going to look at, or we're going to get our midpoint. So int mid is going to be equal to left. We can actually do it as, we're going to do it as left plus our right minus our left divided by 2. This is very simple and standard for a binary search algorithm that calculates our midpoint and also deals with extremely large values where we don't want to add two extremely large values together. And after that, we can then check if our items of mid of 0 is less than or equal to our target price. Then we can update our max B. So max B is equal to items of mid of 1. We will then shift our left value to be equal to mid minus 1. Otherwise, if our value is not less than our target price, we are going to shift our right value. So this is going to change our midpoint and shift what element we're looking at. So when we shift our left point to the right, or sorry, yeah, it's going to be shifted to the right because we need to do mid plus 1. When we shift it to the right, we're then going to look at a new midpoint. If the current midpoint does not have, or is not less than or equal to our element, we can shift it to the left one by doing right is equal to mid minus 1. And that is it for our binary search. We can then return our max B. And that's it. We finished this code. So if we run this, passes our test cases, and if we submit it, passes all solutions. Thank you, and follow along for more daily LeetCode solutions.